pretty much all that he told is correct. I was there at the company when he was there. He stayed for slightly longer, but yes, it was an interesting ride at MySQL. Some things were good and some things were just horrendous. So I'll fess up and say that OpenQuery, which essentially is a services company just like MySQL and Percona and others, we tend to deploy MariaDB. We like it a little bit better than the Oracle releases, and that is mainly because of maintenance and monitoring capabilities. The reason for that is fairly simple. Oracle has MySQL Enterprise, which is a service product. As part of that product, they give you various monitoring tools which sit outside of the server. Of course, they'd like you to purchase that service contract, therefore they keep it outside the server. I don't care for anyone else's business model, I just try to do right for my clients, so I like those same tools inside the server so that there's no additional overhead, no additional bits to break. By the way, this was the same argument I had in 2004 inside the company when the very first iteration of MySQL Network, which is now MySQL Enterprise, was getting developed. The argument is basically, why would you do something outside of the server to track things when the information is already inside the server and you just stick it in a log? So this is one of the things that was done with patches at, for instance, Google earlier that went in our Delta builds that OpenQuery built earlier, that then went into both Percona and MariaDB for 5.1 and above. So Percona has some of those patches, but not all, and that is the short guide there.
Time to stop.
Yeah, that's fine. Go for it. Don't worry, I've got enough time. I'll know. So what time do I need to end?
12:20.
Okay, cool. I'll be there. Okay, so that's the short story. Now, a little bit more addition in terms of MariaDB versus Oracle. The one concern I have at the moment, and I absolutely agree with Stuart, Oracle has done excellent work. They've put a number of really, really good people on it. The numbers, we don't always see their names. They're not necessarily active externally, but they're doing a lot of work internally, and the releases do come out. So that's all really good. The one concern we have is that when Oracle purchased Sun, there was an issue with MySQL. And that was mainly discussed within the European Union in terms of, well, MySQL is effectively a competitor with Oracle in the marketplace. They don't provide exactly the same thing, but that's another long story. And anyway, what happened was Oracle made a commitment to the European Union that they would provide something like $25 million over a 5-year period, something like that. That ends sometime this year. So without that commitment in place, we don't know what will happen. We have no particular reason to believe they changed, but there's also no particular reason to believe that they're continuing. We just don't know. So that at this point would be my concern. I'd like to see later in the year what actually goes on, and then the next release after that, whether actually work has still been put into it. Unfortunately, Oracle doesn't have a fantastic record when taking over companies and keeping the products that come into it alive. MySQL would be a welcome change there. From the global market perspective, there's excellent reasons to keep it there, but that doesn't necessarily mean that there's a business reason to do so, because compared to Oracle's big income, MySQL is a tiny part. You know, so from the business perspective, I could understand it getting ignored, or from a strategic perspective, I could see the development being ramped up further. I don't know the answer right now. I'd like to see that. At the moment, we deploy mainly MariaDB, a little bit of Percona as well, depending on our client's needs. So we tend to find a stock Oracle MySQL installation, and we tend to recommend using MariaDB because it just makes our life, as well as the client's life, slightly easier. I agree with Stu, you have to regard it as a major version upgrade. So it does take a little bit of care, but once you've done it a number of times, and our engineers have, it becomes much easier, obviously. If you're going to stuff around with it yourself and you've got lots of other things to do, then it's not the most comfortable process. Okay, so what we're talking about today is indeed Galera Cluster, which Stuart already mentioned. And the little tidbit that I put in that got the attention of the program committee here was that you can actually replicate across data centers in a synchronous and an active fashion. So that got me into the program for the first time in 4 years. So quite pleased with that one. Okay. So again, little overview. You've heard most about it already. Okay, so I'm not going to go into that in detail. Now, what my company OpenQuery, based in Brisbane, focuses on is preventing problems. And at some point, I was sitting at a dinner at the LCA in Wellington, and someone asked me, so what does your company do? And I took a look around the room and saw that ceiling light, and it had a broken light. I said, that's what we do. We make sure that even when a server fails, the system as a whole, your entire environment as a whole, stays online. And that is really the key. I don't care whether an individual computer fails, or I should rather say, I don't want to care whether an individual computer fails. And why don't I want to care? Because my company does not provide emergency services. That has been a specific choice, and it's been very significant in terms of our company structure and the type of people that we hire. So I don't need to ask a hiring candidate whether they're willing to do evening and weekend duties with their little kids, whether they like being called out of bed at 2 a.m. on Saturday morning. By the way, who here likes being called out of bed at 2 a.m. Saturday morning? Yes, exactly. See, that reduces the interest factor significantly when you're trying to find new employees. People will do it, but do you still do it, Trent?
Yeah.
But you don't actually stick your hand up. You don't actually want, that's the thing. See, I used to do it, and it's not enticing. So we try to prevent it. Now, there's an argument that it might be necessary, but it depends entirely on how you focus on your infrastructure. So what we try to do with OpenQuery is try to build the infrastructure in such a way that it's okay for one machine to fail because the other ones will keep running. That's a different story, but it does tie into what we're talking about today. So by necessity, the MySQL part of any infrastructure will involve some form of replication. And that is for maintenance purposes, as I'll explain in a moment. It is for resilience purposes, but it's also just for ongoing backups, reporting. There's all kinds of reasons to use replication. So even with Galera, there is still a use case for the old style replication. And I'll call it classic replication from now on. So the terminology in here and in Galera training, which we do, just uses the term classic replication just to distinguish it from Galera. Have to make up the terminology because otherwise people get confused. Everybody familiar with the basic layout here? Okay, I won't spend any further time on that. It's just an overview, okay? What we have often deployed over the last 7 years that the business has been in operation is master-master with MMM. Now, how many of you are familiar with MMM? And then I'll ask another question. The multi-master, okay? A couple of handfuls. How many of you have looked at it and thought, oh, this is hideous, I don't want to touch it? Yeah, okay, fair point too. It's not pretty. It's a bunch of Perl. It does some evil things. It also does some very useful things. Let's put it this way. MySQL replication has some bugs. We are aware of it, and it runs most of the web. It works pretty well. MMM is approximately in the same category. Once you know it and you know what kind of evil it can do and you're familiar with it, it is okay. So I'm not saying please dive into it today because it's the most fantastic thing since sliced bread. I'm just saying it is okay, provided you actually know what you're doing. So for deployments where we provide some of the support, that is actually a good place for it to be for that particular purpose. More recently, tools like MHA have come along, which are conceivably better, but they're fairly new, so they'll have different bugs. So it's a matter of getting used to them. In my company, we're more used to MMM at the moment than we are to MHA. So if we have to do a quick deployment, we'll still pick MMM because that's more comfortable, and we'll make sure that it actually works at that point. The reason we've done master-master, so essentially each master is a slave of the other side, is that we can do in-place upgrades without the front end caring. One of our clients is SBS, the Broadcasting Corporation, so all their online stuff runs on MySQL backend stuff that we at OpenQuery maintain for them. And we don't host it, but we help service the databases by remote. And do you ever see a scheduled outage sign on those websites? You don't. And that is the thing. There's no such thing as scheduled outage when we design the infrastructure, and that is quite nice. So we can actually switch from one master to another to do schema upgrades, version upgrades, other evil stuff that wouldn't otherwise be possible online. Of course, you can swap out a slave at any time, but the master is slightly more tricky. So you don't use master-master for scaling, because any write query that gets written onto one needs to get written onto the other one, and it's even worse, because with replication, classic replication, it gets replicated in a single thread, at least until very recent versions where it can get multi-threaded across multiple databases. So, it's not for write scalability that you do this kind of setup, it is for convenience of maintenance and so on, and resilience. When there is a problem with one of the servers, we can switch to the other one, and that is the thing that MMM controls, and it's done automatically. Okay? Relay slaves would be to another part of the data center. Regular slaves are to do read scaling, which is generally relevant with web applications, which do more reads than writes. Reporting slave, that is relevant because reports do significantly different queries. They do more complex queries. For instance, you're scanning entire tables, you're doing complicated group bys, and then max, min, average, sum, all those things, but you're actually scanning large data sets. You would chew up most of your caching, and you will actually want larger sorting buffers and so on than otherwise, but you might have fewer connections. So if you run it on a separate reporting slave, that actually works much better. Okay, so that's why I've separated that in the story. Now, onto Galera technology. So all of this stuff I just discussed still exists. With Galera, it doesn't mean you can't use that anymore. It's still there, and you can use it both together. Of course, that comes with extra fun, but it's not too bad. You can read as well as I can. I'm not going to repeat all of that. It is synchronous replication, and of course, every definition of synchronous is slightly different, so I'll explain in detail in the diagrams what exactly I mean by that. Just to give you an example, when we're talking about ACID compliance, when it comes to the old MySQL cluster, NDB cluster, ACID compliance traditionally means for durable that you actually have f-synced to disk. Well, when you write to a SAN or to a RAID controller, the RAID controller says, yeah, sure, I've written it to disk, and we know it's in the memory, not actually on disk. With NDB cluster, ACID durable means that it's at least in 2 nodes on the cluster, but it's mostly in memory. It may not have been written to disk at all. So it gives durable a little bit of a different definition. Same thing with Galera and synchronous. It depends on the technology that you use exactly what synchronous means and what durable means and so on. Okay, it works only with InnoDB or the Percona enhanced ExtraDB. Yeah, no MyISAM, no anything else either. Just for the record. So that does mean, I don't know how many of you went to the Open Programming OQGraph talk yesterday. Anyone? Okay. So the new OQGraph version 3 engine actually uses an existing engine rather than having its own. So it would be able to use Galera now because you can run it on top of InnoDB. So that's for graph queries. Okay. So let's see what the system looks like. So that's basic overview of what MySQL looks like in 5.5 and up. It has a bit of an replication API. Now, when we talk about APIs in MySQL and MariaDB and plugins, it is not always that simple. Generally, to make a plugin work reliably, you need to actually compile it at the same time in the same environment as the rest of the MySQL server, because not all the behavior is encapsulated in the plugin interface. So while the plugin interface remains stable, there are other things in your build environment that can make things break badly. Okay? So this is one reason why we don't build the OQGraph engine for the Oracle MySQL, because I don't have access to that particular build environment. And we're very happy that MariaDB 10 has just remerged the latest version in there, because it lives in that tree, it gets built together with it, and so on. So when we talk about plugins, yes, it's plugin, and you can load it at runtime and unload it at runtime and not have it pollute the rest of the code base in your memory, but it's not something that you can grab from vendor A and vendor B and toss together, just as a word of warning. So there's replication API, and wsrep is a library that ties into that. Now, quite interestingly, wsrep wasn't actually written for MySQL at all. So I'll tell you what the history is. One of these arguments, I forget which one it is is actually about 15 years old. It comes from a very large database conference, a VLDB conference around 1999. And around that time, someone actually implemented this for Postgres. Isn't that interesting? And it was one of the candidates to be implemented, to be used for Postgres replication. For whatever reason, this one wasn't picked. I think that's unfortunate, maybe, but there possibly were other reasons, other advantages that the current replication mechanism that was chosen to be put into Postgres does possess that this one doesn't. Anyway, it's an older idea, not particularly recent, but it replaces the old two-phase commit mechanism. Who here is familiar with two-phase commit? Okay, I'll explain what two-phase commit is in a moment. I'll stay here to explain that. So what usually happens in a cluster, and this is why you need to put all the nodes in the cluster really, really close together, maybe use special InfiniBand network cards or Dolphin interconnect network cards like you would use with NDB cluster. You want to have the latency between each of your servers as short as possible. What happens with the two-phase commit is there's a prepare stage and a commit stage. So at the end of your transaction, which could be a single statement, you need to tell the controller of the transaction, that's usually where the transaction is run, that machine, tells all the other ones, are you okay to commit this? That's the prepare stage. And if they report okay, then you tell them all, commit this all. And so the whole conversation goes around the cluster twice, 2 phases of the commit. And this is why it's freaking slow if you have more latency. Now imagine putting one or more servers of an NDB cluster system in another data center. Your performance goes, it just doesn't work anymore. Okay, so that's why that then tends to not happen. So to do cross-data center replication or intercontinental replication even, you essentially need to get away from the two-phase commit mechanism. Now unfortunately that was pretty much the only party in town up to when this was implemented. So group communication takes a slightly different approach. So at commit stage, there is communication to the other nodes in the cluster, through the replication stream. And that replication stream, by the way, is not the same as the old binary log, read from the binary log, and so on, like classic replication. It is through this library, the wsrep library. It's a different mechanism. It can even use, It's multicast on the local network. So there's some efficiencies that can be used in there. So a transaction is communicated to all the other nodes in the cluster, and that is all of them that are currently in the cluster active rather than catching up or doing something else. And each of the replicants, which is again a term I came up with to just clarify what happens. So the writer asks each of the replicants, essentially at the same time, will you be able to commit this transaction? Not necessarily right now, but will you be able to commit it given the other things that you've been asked to do? There may be other active transactions on that system that might conflict with the transaction that's being asked to be written. So at that point you have to return a deadlock error. In any case, you have to report something back. In this case, Galera chooses to use a deadlock error. So it may also be that the system is still busy writing a couple of other transactions. There might be some queued up that haven't been written yet, but it has to take those into account and actually report back honestly. If that is all okay, then you can just say, go ahead. So there's a communication around the cluster. They're all asked, they provide the answer, and then they're all told, go ahead. But you don't need a response back for the go ahead. It doesn't matter. If the machine dies at that point, it'll catch up from another node in the cluster. The usual recovery procedures apply. I'll explain about that in a moment. And if it does apply, I don't want to hear it back either. So this is where it's called virtual synchrony. It's very likely, given what each of those servers does and their workload, that the commit on a replicant is very, very close in time to what the writer did, but it is not instantaneous. Does that make sense for everybody? It will happen very closely there, but not necessarily at the same moment. What happens in a two-phase commit is once you've done the commit phase, you've asked all the nodes in the cluster and they report back and you know when they've done it. So by the time you report back to your application, you know that there will be a copy in the other servers. With Galera, you're not quite sure, but you may be off by a tiny fraction. You might not even be able to measure it. Question?
On the simplification step, how do what does the writer do when you get back a mixed set of certifications? Some say yes, some say no.
Then the answer is no.
Okay.
Because if one is unable to certify it, and it could be another transaction, that will be sent out shortly, you get a giant mess. So what happens is in Galera, it just uses you essentially need an error code for it, and the communication mechanism is a deadlock error. So when you get back a deadlock error, which can happen on any statement anyway in transactional processing, in Galera it tends to happen on a commit. So you can send a commit command as an application, and you get back deadlock error, you need to rerun your transaction. Yeah? I see a slightly fuzzy look. We'll get back to this. It is standard transactional processing. If you run any single statement, really, you should check the errors. Yeah? And this is it's not a fatal error. It is what I call a transient error. It's similar to a lock timeout, or I've lost a connection to the server. You would have to reconnect and sort it out. Developers who have worked with Oracle are very, very much used to this. Developers who work with MySQL as a basic background tend to be complete slackasses, and I count myself among them. You kind of presume she'll be right. And that is just a bad habit. Particularly happens in PHP land, of course, because that's just the broadest group. But yeah, there's a lot of code out there that just, even when running a transaction, presumes that the transaction will just go ahead, it'll commit, it'll be right, and if it doesn't, it'll chuck an error at the user that they don't understand. You know, it's that kind of stuff that needs to be fixed anyway. Well, guess what? When you fix it, you'll be ready for Galera because it'll actually work properly. So, yeah, and otherwise, it'll work as well as it did before, except you may see slightly more errors. Let's put it that way. Because of the Galera environment, you will see more deadlock errors, which means, you know, you'll pester your users with bad behavior a little bit more. Okay. So once the certification is done, that's registered, and the commit OK is sent to all of the replicants, and they can do things as they wish. In Galera, the slaves or the replicants are multi-threaded, so they can actually work and process multiple transactions just like a master server does. All of them are masters. Okay, so it's not a serialized thread like with classic replication, where one statement has to be after the other one as the basic setup. So how does that work out then in terms of your infrastructure? Well, it's not a case of one master, two master. It's a many master, something like that. So you could run a load balancer between all the servers, because it really doesn't matter which one you talk to. They're all equal. There's no primary and backup. Well, you could define them, but that's just between you and your piece of paper where you define them. It doesn't actually matter from the configuration perspective. They are all equal. So the example here uses two load balancers because, you know, the load balancer can break. The usual. Anything can break. Okay?
Is it the TCP/IP load balancer or just
yes.
like MySQL proxy?
I would tend to go for TCP/IP, but it could be, for instance, HA proxy, which is very good at what it does because it's existed for a long time and has been used in big Linux clusters. You know? Does that also do proxying?
No.
Like, yeah. So but for keeping an eye on things, yes. We'll go back to.
Proxy is just another LDS front-end.
Oh yeah. Okay, got you. Yeah, I'll get back to the monitoring of this whole thing and keeping an eye on it. I'm not really a fan of MySQL proxy. The guy who wrote it, Jan Kneske, absolutely awesome, love him to bits. But it introduces an extra part in between your application and MySQL server. It will cost you about 5% of your performance, and it's an extra bit that can break. It has a Lua interpreter in it. It's really, really flexible, and what could possibly go wrong? Some awesome things have been done with it, but you know, I prefer to not have that piece in between because things can break, and I don't like it. People have, like I said, people have tried to do stuff there that should have really been done in the server, and in many cases those things have just been implemented in MariaDB, so I don't have to worry about it. So I would really recommend you go HA proxy or a hardware load balancer or something like that, because the problem is not complicated. It doesn't need the intelligence and the complexity that MySQL proxy introduces for you. I mean, the simple and stupid mechanism would be tell your applications where all the servers are and just make them go at random. You can use extra trickery for that, but that would be the very simple version that doesn't have any intermediate steps.
Those MariaDB instances may be in different data centers?
Yes. Okay. But then you shouldn't load balance to another data center from your application.
Like DNS for local
yes.
affinity and stuff.
Yes. Yeah, so each of this, you would replicate this whole setup to another data center and do the same thing again. Yeah? In whatever many you want. Okay, so conflict resolution. So Galera replicates before commit, as indicated in 2 slides ago. And globally, events are ordered. It has to do so because things can be relative to something else, so you need to have some kind of agreement what comes before what. So that is why replicants can report back, I will be able to commit this, because given the order that they've agreed between them, I will be able to do that. There won't be any conflicts. It can actually predict that. Okay? So, should an event n conflict with n+1, then n+1, that particular event is set to fail, certification can't be applied, deadlock code is reported back to the client. The client can just rerun the transaction just like any other application should. And other slaves can just ignore the failed event. So if they get asked, can you commit this, and they never hear anything about that again, then they'll just toss it, because they haven't been told to actually commit it, even if they've reported back, yes, I can. Okay, they do need to be told later on. Yes?
What happens if you, so presumably when you ask a slave, like, can you commit this, it will consider other things that it has been asked to commit but has not committed.
Yes, plus its own, the things that it has been processing locally. Yeah.
Things that it will consider conflicts with are things that have been staged but not committed.
Yes.
You're basically saying that there's no explicit cleanup of staged commits. They sort of just like fall off the cliff eventually. Is that what you're saying?
I don't exactly know how it's implemented.
It sounds like for conflict avoidance, you would want to explicitly clean them up. Otherwise, you sort of just like fail things or just like linger in constant conflict for a while.
No, I don't think that is the way it works. But I don't have a complete answer for you. Sorry. Would need to dig into the library and see what is going on this week. So, yeah.
And how are things ordered globally?
They have a global transaction ID, which is agreed between the servers.
But all of them are, it's master-master, so
they can all commit. There is in a cluster that tends to be one. There's a little bit of extra communication going on that sorts that out. Let that be the short version of it. And again, I should explain that the wsrep library can actually work independently from MySQL. So it's not something that MySQL implements. It's something that library implements. Okay. In principle, it would even be possible to replicate between MySQL and Postgres using the same library. I'd like someone to implement that. Yes, I think that'd be entirely sensible. Would be good. Okay, so really important again, even a commit can return an error, and it will be a deadlock error. Okay? So, what should you do before you can actually use Galera? Stuart mentioned it's a drop-in. Wouldn't quite go that far, depending on what your existing setup is. This is the compacted version that we use as our pre-deployment checklist. If any of these fail, we are not going to deploy Galera for you or with you. You're just not ready. So the consequences of any of these are somewhat indirect in some cases, but this is what it gets down to. Does that make sense? So when you read through the old documentation, you see, oh, you can't do this, you can't do that. Well, it's listed in there somehow. Okay, so all tables must be InnoDB or ExtraDB, which is essentially the same thing. MySQL system schema accepted, but we'll get back to that. You can't muck around in the MySQL system schema directly, so you can't edit the user table or the the DB table, any of those privileged things. You need to use grant, revoke, create, drop user, those commands, and they get replicated appropriately. No general slow query log to CSV table, so again that affects the MySQL system schema where those tables reside. it wouldn't be possible to replicate those. Yeah, they would create replication events, but they can't actually be processed because it's not InnoDB on the other end. It doesn't work. Because it's not InnoDB, it's not transactional. Because it's not transactional, at least CSV is not transactional, it can't actually be isolated and serialized properly, so you get a giant mess. So it just doesn't work in that way. All tables must have a primary key. Now, the reason we say that is because, yes, in theory, wsrep should be able to handle a situation where a table does not have a primary key, but it depends on which version you're running and a couple of other phase of the moon and so on. So we just have a basic rule, please just have a primary key. The other reason is that InnoDB's performance, if you don't have a primary key, is horrendous. Its locking behavior will be different, and you will find that your performance is bad. Yeah? All tables in InnoDB must have a primary key, just a basic rule. It doesn't necessarily have to be an auto-increment. There are reasons in certain scenarios when you don't want an auto-increment, but it does need to have a primary key. Okay? Yes?
Do you know if that's true for Rails applications?
It is true for InnoDB. So I don't care whether Rails does, whether Rails does it or PHP does it, but yes, you should always have a primary key. Now, in Rails, you tend to have a fairly sane design. So if you go by the general conventions, you will have a primary key in every table, or in a linking table, you will have a composite primary key, which is a foreign key of a couple of other tables. So it tends to work out. If you bring me a schema overview and show me a schema, okay, it doesn't have a primary key there, why might that be and what can we do about it? I'm happy to have a look. I haven't seen anything that doesn't comply with what I've just said. It is abstracted out, but Rails tends to do the right thing. Now, Rails tends to do the right thing. So while Rails developers don't necessarily know a lot about database design, the conventions that they use make them end up in third normal form in terms of regular design, and the schemas tend to have the proper primary key. Now, they don't necessarily have the appropriate other indexing. That's a matter of the DBA or whoever deals with the schema to actually do that properly, but the basic design is not bad at all. In fact, many of the Rails schema designs are much better than what you see in the PHP realm, because the PHP person has done it themselves, and the Rails person has done it using the conventions, and the conventions make them behave, even though they don't, well, technically they don't know what they're doing. In database design, they do the right thing by using those conventions, so I'm quite pleased with that. Hire a Rails developer, because they have learned correctly indirectly, okay? Yes, and repeat again, please do proper transactional processing. So who here does proper error handling of all their SQL queries? Is at least an honest answer. Yes, I can't even promise that one. I try to, but it might have, I was a slack ass way back as well before I learned to do the right thing. The devs you work with don't. Yes. It is very detrimental to the proper look of your application. When you're chucking errors at your users, it is not a particularly shiny thought, and failing on errors, failing on transactions and then not handling them means that something gets lost, and that is never what you want. I mean, if you meant to commit a transaction, I'm sure there was a reason for it. So it needs handling and it needs fixing, and I'm fully aware that it's not easy to fix in an existing app, and everybody will claim that it wasn't their app to begin with, but they've been landed with it and they need to fix it over time. It's a fact, but it does need to be dealt with. Okay, quick overview of the very, very basic settings. So the libgalera is the wsrep library, which is just a shared library that gets hooked in. The cluster address is on a particular port. Like as I said, it can actually multicast on the local network, which reduces your traffic a bit, which is nice. And then there's a setting there. I'm not sure that's still active in the current version, but it was: do we wait for a primary server before we actually start the system or not? It depends a little bit on whether you're bootstrapping the cluster or you're doing something else. Then the authentication between the cluster nodes has a username and a password, so it can actually log in and so on. Server ID equals 1. Of course, you want that to be unique. The binary, the binlog format has to be row-based. You do not have a choice. It cannot be statement-based, it cannot be mixed, it has to be row-based, okay? The default storage engine should be InnoDB, just to keep you out of trouble. Now, here's where it gets interesting. Maybe this one has changed actually, because the Galera people at Codership have done a lot of extra work. So in some cases, I've actually removed things that were true earlier that are no longer necessary. They've made things more flexible. So the auto-increment lock mode is 2. I won't go into detail on that now. It's not too complicated or not too much to worry about. The last one is of interest. Who will tell me as a little quiz what it does? Flush logger transaction commit. You should know that parameter. What should it normally be set to? He gets the prize. Trent gets the prize. It should be at 1 because?
Well, because basically make sure that all your InnoDB data is actually flushed out to the disk and not just in memory where it might be lost if the server crashes.
Absolutely. If it's not set to 1, it's not asset compliant, which would kind of fail the whole story of why we're using InnoDB to begin with. We care about our data, right? Okay, so what happens when you set it to 2? Instead of being f-synced on commit with some grouping involved depending on which version of MySQL you use, MariaDB 5.5 does a group commit, and I think Oracle MySQL does it in 5.6 or something, does something similar. So multiple transactions might use a single f-sync rather than actually slowing the server down further. Essentially, the server performance, what we usually find, is limited by the number of f-syncs you can do per second. That is by far the slowest thing you can do. So you want to reduce that number. Now, this is what reduces that number. When you set the transaction commit to 2, it will f-sync only once a second. Now, this sounds a bit scary because we're no longer f-sync on every commit. Now, why is this okay? Anyone? Exactly. We do have a cluster. We have more than one node. Therefore, it is okay. So we're improving the performance on a single system because we are in a cluster. So when you move from one node to 2 nodes, the performance of the one node is already going to be higher because it's not going to be slowed down by the f-sync limitation. Okay? So that's much nicer.
Is that a requirement or a nicety? Like, is that a requirement to be 2?
No, it's a nicety. You could keep it at 1, but you'd be hurting yourself. It is not beneficial and it will actually hurt your performance. Because the cluster, of course, does introduce a little bit of overhead. So by introducing this overhead as well, you're just damaging the situation. You will actually potentially lower your performance depending on the latency. Okay? So we're trying to do as much as possible to increase the performance without damaging the reliability. Reporting. Each node can report externally. It can call, the rough version is it can call an external command. I kind of skipped over it, but it does similar things to actually start up a new cluster node and to actually do recovery. So an empty cluster node knows about its fellow cluster nodes, and through the communication with at least one other, it learns about that, and it can actually run fsync, MySQL dump, not fsync, rsync, MySQL dump, or another tool to grab the bulk of the data to initialize itself. So it's completely different from classic replication, where you need to provide whatever scripting or magic involved to seed a new slave or new server. In MySQL cluster, that is built into the infrastructure. You need to say which one you want. You need to potentially write a script if you want something funkily done, but it is absolutely built in there. So cluster nodes can also report externally, so they can report to an external destination, which can be monitoring tools or load balancing. So it's not the same as those silly SNMP trap. Hi, I'm a SAN, I'm crying in the corner, I'm going to die, and now I'm going to tell you that I'm going to die, because that doesn't work for kind of semi-obvious reasons. It won't be the server dying that tells you. It'll be all the other ones in the cluster. Okay, so the load balancer will get a lot of notifications from all the other servers in the cluster saying, he's dead. Okay, now you could apply some logic to that and say, okay, I've got 5 servers. If 3 of them say that that number 4 is dead, then I don't need number 5 to tell me as well. You know, you can apply a bit of rule set to that, but the point is you can get those notifications out there. You don't need to rely on one monitoring system to keep an eye on that. So you have a little bit of resilience now built in to your monitoring, but you do need to change the way you monitor this and the way you control your load balancer to know which things are online and which things are offline. Okay? So the opportunities you get out of this different infrastructure that you now have, you now no longer have one master or dual master, you have many masters. So you get a higher write scalability. The obvious question would be how much? Now, Codership has done a graph based on a benchmark they did on Amazon, and I was severely displeased with the lack of information about the environment on which they ran it. So I actually removed that graph from my slides. OpenQuery is running its own test, and I'm not yet happy with the results. That is, the output I'm seeing doesn't make me happy or unhappy in terms of performance. It just doesn't make me happy in terms of the overall environment. So we're still mucking around with it. So stay tuned. It'll be on the OpenQuery blog when we get it. And yes, it'll be fully published with the scripts. So essentially, you can, if you have Amazon instances available, it's scripted. So it'll say, start so many servers, do this, and go out there and do it and get your own numbers out. So that will allow you to then potentially test it on your own environment. And that is actually the key thing. People ask us quite often now, okay, we've heard about this Galera thing, sounds really cool, so what will we get out of if we deploy 4 servers? And the obvious, no, not so obvious maybe answer, but really honest is we have absolutely no idea, because it will really depend on your infrastructure. If you're not running on Amazon but on your own infrastructure or virtualized server somewhere else at the hosting provider, it will depend on how that behaves, what the latency is between the servers, and also what the application does. If it's predominantly read, you may not get a lot out of the write scalability of Galera. You know, you're not going to benefit. If you were kind of going against the write capability of your current environment, then Galera is very likely to help you. Yes?
Can you use normal slaving off
yes.
some of those masters and then
yes.
read off those for read scalability?
Absolutely. The issue will be, and there's no infrastructure for that, no tools necessarily, if the system you're hanging off is dead, that slave doesn't magically reconnect. So you'd need to hack up something similar to MMM to actually move it across. Yeah. That's the only caveat, because it's not part of the cluster. It then goes on and it doesn't care. The classic replication doesn't care about Galera and vice versa. Just like in classic replication, nothing cares about nothing essentially. A slave can die and the master doesn't care. You need monitoring.
Would it be possible to hack up some kind of
depending on your needs.
I don't know, something like PRBD and a couple of masters that are part of a Galera cluster and that have slaves coming off them?
You can definitely do a Galera cluster with a number of slaves, but yeah, you'd need to script
so fail
with failover. So you'd need to script and provide the appropriate tool set to keep an eye on that and make sure it actually gets moved appropriately. Moving a slave is not entirely trivial because it needs to connect at the right position on the other end. Yeah. So there are tricks for that which MMM and other tools apply. Yes.
Didn't you say that it already used the global position?
Yes, correct. But that is in the wsrep library, not in the binary log. Very unfortunate. Now, depending on which version of MySQL you have, there are global transaction IDs. So I will expect at some point for those two to be merged, and you will have a global transaction ID regardless of what you do. Yes, I'm fully with you. Yes, there is a global transaction ID, but it's not in the place where you need it for this particular purpose. So, you know, that's one of those things, it's a plugin and hasn't talked yet. So, tools or possible uses, applications that don't have master-slave logic. There are some applications, maybe it's from another vendor, and maybe it's even closed source stuff, and they don't know when to collect to master or connect to slave. You don't have a choice. Well, in that case, Galera is now an opportunity to actually scale out that particular system. Okay? So for some of our clients, that has been a nice solution, but it is a specific use case. Cross-data center interests me much more because we have done cross-data center before, but it's essentially a passive set of slaves on the other end in a replication chain, and then we need to change the replication infrastructure the moment we fail over, and it is very much a primary and a secondary just because of the way classic replication works. So with Galera, they can be active. Now, for stability and practical reasons, you would want at least 3 Galera servers at each site. Yeah, possibly more. If one fails, you need another one. If one fails completely, you need one other to be temporarily offline. 1 minute, yeah. Temporarily offline to update the rest. Yeah, so that means you would only have one left. So 3 or more servers would be the minimum you would run with. Okay, so you would do it active and make sure that your web applications only connect locally. Please only connect locally, because the latency is just ridiculous if you connect from an application to another data center. It is not a good thing. There's a lot of communication. TCP/IP alone has ridiculous overhead there, let alone when you start doing database queries. So you're no longer dealing with primaries and secondaries, primaries and data recovery sites. It is all active. You can do it with 3. It doesn't really matter in that sense. How much latency is in there depends on the distance between the data centers, obviously. It is very much about latency, not about the width of the pipe. So that is something to keep in mind. I don't care whether you've got 10 kilobit or 10 megabit. If your latency is bad, then that is something to think about. So it's very much something to test. And again, that's something to test with the tools that we're going to publish. Okay, questions?
If you got replicating to another city, for example,
Yes.
will the time for replicating, say, to Melbourne from Sydney, is that going to affect the use of the machines in Sydney? Is that going to slow things down because you've got to wait for that communication with Melbourne to finish? Okay, so the question is, if I'm replicating between Sydney and Melbourne, will the fact that I'm replicating to Melbourne affect the performance of the servers in Sydney? Does that summarize it? Okay. Well, when you commit, it will delay slightly because the communication has to go to Melbourne and back to get confirmation that the transaction will be committed. So that is the delay. So, I don't know, 100 milliseconds extra. Yeah. Other things can at that time still happen in Sydney. That doesn't really matter. But the usual deadlock rules apply. So if your transaction does something that locks a lot of rows that then interfere with other people doing other stuff, then there could be an extra wait for someone else. But for many operations, because InnoDB, it does lock-free selects and it does row-level locking, it doesn't lock many things. So it's not too bad. Okay?
Sorry, we're out of time.
Cool. Catch me in the hallway. Sure. Thank you.
Thanks.